Welcome to this video to talk about free energy and reaction rates of chemical reactions. We're going to break up this video into a series of questions about chemical reactions. Question number 1, is the reaction endothermic or exothermic? With endothermic, energy will be required or absorbed in the reaction. Exothermic, energy is released. What are some great examples of this? Well, if you take a hot pack, inside the hot pack is magnesium sulfate and water. And when you mix those together by kind of crunching up or squeezing and mixing the contents of the hot pack, energy is going to be, or heat is going to be released. And so in this case, heat is released. And we're going to call this an exothermic reaction. Again, because heat is released. And in the reaction, heat is a product. In the reaction. Really, it's a product. On the other hand, if you have a cold pack, when you squeeze together the contents, mix them together, ammonium nitrate and water, it is said to be an endothermic reaction. Heat is absorbed. And in this case, heat is a reactant. Why does a cold pack feel cold? It takes heat from your hands for the reaction to occur. It's a reactant. And so heat is absorbed by the chemical reaction, taken away from your hands, so it feels cold. So question 1, how do you know if a reaction is endothermic or exothermic? Does it release heat or does it absorb heat? That's how we know. Now, as we move forward with these concepts, we can be introduced, or you can be introduced to something called a reaction diagram. Sometimes this is called a reaction coordinate. It really allows you to follow the progress of a chemical reaction. You start right here with a reactant in a chemical reaction. You proceed over something we're going to call the transition state of the reaction, and then you end, obviously, with the product of the reaction. And this diagram or coordinate gives you information about the reaction. And one thing it tells you is if a reaction is spontaneous or non-spontaneous. The reaction diagram will tell you this. Now, we're going to use the capital letter G to stand for free energy. Let's just call it in this class energy. And you can see the reaction diagram gives you a starting energy of the reactant and an ending energy here of the product. And so the difference in energy between reactant and product will tell you if a reaction is spontaneous or non-spontaneous. A spontaneous reaction is not driven by an outside force, which is typically requiring some type of input of heat. But technically, the definition of spontaneous is not driven by an outside force. So how can you look at a reaction diagram and know if a reaction is spontaneous or non-spontaneous? Well, we can calculate something called delta G Rxn. The change in, delta means change in, the change in free energy or energy of a reaction is the energy of the products minus the energy of the reactants. Well, let's look over here on the left at this reaction diagram. There's no numbers on this diagram, and there doesn't need to be for this discussion. I think you can see clearly in the reaction diagram on the left the energy of the reactant is higher than the energy of the product. Because you look right here, there's reactant, there's the energy of the product. If the energy of the reactant is higher than the energy of the product, then when you go to this equation, delta G Rxn, it will be negative. It will be negative. So a negative delta G, or a delta G less than 0, indicates you have a spontaneous chemical reaction. And again, the only way you're going to know that is to look at a reaction diagram and note where the reactants and the products are in the reaction diagram. Let's look to the one on the right. It's non-spontaneous. That is, delta G is greater than 0. The change in free energy of the reaction is greater than 0. How do you know that? Well, look at the energy of the reactant. Look at the energy of the product. Clearly, the energy of the product is higher than the energy of the reactant. So delta G is going to be positive because delta G equals the energy of the products minus the energy of the reactants. So the one on the right, you have a positive delta G. That is, delta G is greater than 0. So, given a reaction diagram or coordinate, you can predict whether a reaction being described by the coordinate is either spontaneous or non-spontaneous. And again, spontaneous is one that's driven by an outside force, typically the addition of some type of heat or energy. All right, well, what else can we do with these reaction coordinates? Well, we can address question number 3. What determines the rate of a chemical reaction? The rates of chemical reactions are very important. And what we know is that there is one term that directly governs the rate of chemical reactions. It's called activation energy. And let's just abbreviate that, AE. How are you going to determine what the activation energy is of a reaction? You need a reaction diagram or coordinate that you will be given. The definition of activation energy is the following. It's the difference in energy between the reactant of a chemical reaction and the transition state of the reaction. Again, TS equals transition state. Where is that transition state indicated on a reaction diagram? Right here. It is the highest point in the diagram. So really, what you are looking at here are two reaction diagrams for two different reactions. One is a faster reaction, one is a slower reaction. How are you going to be able to pick out the difference here? Before we do that, I will say, and I'm going to write this on the side here, both number 1, let's just call this number 1, reaction diagram, reaction number 1 and reaction number 2, described by their reaction diagrams, are both spontaneous reactions. So this goes back to question 2. So in both cases, the product is lower in energy than the reactant. So here, A going to B, this is what this reaction is being, being characterized. A going to B, C goes to D. Both of these are spontaneous reactions because the energy of the product is lower than the energy of the product is lower than the energy of the reactant. So both of these are spontaneous. But that does not tell us anything about the rate of reaction. The rate of reaction has to be determined by looking at the activation energy. You have to look at the difference in energy between the reactant, and in this case A, and the transition state. In reaction 2, the difference in energy between C, the reactant, and the transition state. I think you can clearly see here that the activation energy for reaction number 1 is much smaller than the activation energy for reaction 2, because the difference between the reactant and the transition state is much smaller. So here's the general rules. As you increase the activation energy, you decrease the rate of the chemical reaction. Conversely, if you decrease the activation energy, you increase the rate of the chemical reaction. And typically a rate is going to be some type of like moles of product, for example. Some amount of product like moles over some unit of time. So those are the units for rate. Okay, before we leave this page, which reaction is faster? Number 1, A going to B, or number 2, C going to D. You need to look at the difference in energy between the reactant and the transition state of the reaction, and that will give you the answer. This reaction number 1 is definitely faster, and number 2 would be slower. Why is reaction number 2 slower than reaction number 1? It has a higher activation energy. And how do I know that? Look at the reaction diagram that you were given, and look at the difference in energy between the reactant, in this case C, and the transition state. And in number 1, the difference in energy between A and the transition state, and the difference is clear. Okay? Again, the transition state is always something between the reactant and the product, and it's always usually the highest energy species or entity in a chemical reaction. Alright, so we know how to tell if a reaction is spontaneous or non-spontaneous. You got to look at the reaction diagrams. We also now know how to determine the rate of a chemical reaction, or what determines the rate of a chemical reaction. It's the activation energy, and we can look at reaction diagrams and predict rates. Kind of the last thing we want to do here is, how do we speed up a chemical reaction? That's a very, very important consideration in chemistry and biochemistry, because there are times when we need reactions, chemical reactions, to proceed at a higher rate. So when we get into later on in this class, we'll talk about something called enzymes, and they are biological catalysts. And a catalyst speeds up a chemical reaction. If you want to speed up a chemical reaction, what do you need to do to speed up a chemical reaction? Well, you need to lower the energy of activation energy, and you do that by adding a catalyst. A very important term. What does a catalyst do? A catalyst lowers the transition state. Let me write it this way. It lowers the energy of the transition state of the reaction. Wow, if you lower the energy of the transition state of a reaction, what are you going to do? You're going to increase or decrease activation energy. You are going to decrease activation energy, and as a result, you are going to increase the rate of a chemical reaction. That's what a catalyst does. How does a catalyst speed up a chemical reaction? It lowers the energy of the transition state, which lowers the activation energy, which lowers, adding a catalyst will lower the energy of the activation energy. A catalyst lowers the activation energy, which increases the rate of the chemical reaction. Let's do an example here. So here we have a reaction diagram with no catalyst. No catalyst. And you have the reactant A going to the transition state there. We have a fairly large activation energy. Look at the energy difference between A and the transition state, pretty large. But look at this. If we add a catalyst to this reaction, it's the same reaction, it's still A to B. It's still A to B. One is without a catalyst, one is with a catalyst. What's the difference? What's the only difference between reaction coordinate reaction coordinate for no catalyst and the reaction coordinate with a catalyst? What's the only difference between these two reaction coordinates? Does the energy of A stay the same? Is the energy of A the same with no catalyst and with a catalyst? And A is the reactant because we're going from A to B here. The energy of A is the same. The energy of B is the same. Catalysts do not change. Maybe I should write this down. Catalysts do not change the energies of reactant or product, but they do lower energy of the transition state. I think you can see this in these two reaction diagrams. Look at this. With no catalyst, you have a very large activation energy. So you have a large activation energy. You have a slow or low rate. Here you have a much lower energy of activation, because the difference in energy between A and the transition state is very much smaller now. So if you lower the energy of activation or activation energy, you increase the rate. How do we speed up a chemical reaction? Add a catalyst. And you can do that in chemistry. In our bodies, in animals, we have natural catalysts called enzymes that do this. How does a catalyst speed up a chemical reaction? A catalyst lowers the transition state energy in a chemical reaction. A catalyst does not change the energy of the reactant. It does not change the energy of the product. It only lowers the energy of the transition state of a chemical reaction. As a result, the activation energy for that reaction is much lower. As a result, the rate of that chemical reaction is much higher. You are going to have to be able to look at reaction diagrams and answer questions that we covered in this video related to, is a reaction spontaneous or non-spontaneous? Is a reaction exothermic or endothermic? There you just have to know with endothermic and exothermic if heat is released or heat is absorbed. So you don't really know about the reaction coordinate for that. But when it talks about spontaneous or not spontaneous, you have to look at a reaction coordinate. You have to look at a reaction coordinate. When it comes to which reaction is faster, if you have two reactions, which reaction is faster? You need to look at the reaction coordinate. The reaction coordinates will tell you that. Has a catalyst been used in a chemical reaction to speed it up? You can look at the reaction diagrams to tell if a catalyst has been added, and a catalyst will speed up a chemical reaction. All right, that's it. Thanks.